My name is Bill Seguin. I'm a licensed HVAC contractor. Does anybody know what HVAC means? Part of it? Yep, HVAC, heating, ventilation, and air conditioning. Or HAVOC, as some people like to call it, or HVAC. I specialize in geothermal heating and cooling installations in residential applications. We also install for light commercial as well, for new building and retrofits. And when I say retrofits, does anybody have an idea what that is? Well, retrofits means if, for instance, there's an old building, an older building that has an older heating system in it. Typically it would be oil-fired or gas-fired boiler or furnaces. We would retrofit it, meaning we would rip out the inefficient fossil fuel burning equipment and install a geothermal system. I've been in the industry for 32 years. I presently own Seguin Heating and Air Conditioning, and we're located in New Milford, and we've been there since 1983. I am geothermal certified from IGSPA, which is an organization called the International Ground Source Heat Pump Association. I've been certified since 1996, and we've installed over 100 residential geothermal heat pumps in the Fairfield, Litchfield, and Westchester counties. Is anyone here from that area? Or are you Litchfield, Fairfield? How many of you are from out of state? Okay. Anybody from the Midwest? You heard of geothermal? No. Okay, it's kind of originated out there. It's very popular out in the Midwest, because of the green movement that's been happening the last 5 or 10 years, and I'm sure you guys have probably are well versed on that. I'm sure you heard of carbon footprint. Does anybody know what that is? Well, you're probably going to hear a lot about this. You've heard of global warming, right? The melting of the ice caps. How many believe that that's true?
Pick a side, guys.
How many believe it's not true? Interesting. Okay, well, I believe 99% of the scientists around the world believe that it is true. One of the big contributing factors to that is the burning of fossil fuel. In fossil fuel, I mean oil, gas, liquid petroleum gas, and natural gas. Not so much in natural gas, but it still contributes to it. The burning of natural gas is probably one of the most efficient and one of the more cleaner fossil fuels around. There's an abundant source in the United States, and they're tapping into that now. Which is actually a good thing. We install systems that are combination systems of geothermal with natural gas. So that's something that's happening now and will be in the future. One of the reasons that I'm here, and Sandy asked me to come, is kind of fill you guys in on what's to be expected maybe in your future. Because when you get out there and graduate and you get a job, you're probably going to be looking for a house to buy, yes? No? Build a house? Haven't thought about it. And I don't blame you. But sooner or later, when you get out in the world, it's going to be part of your reality. And chances are you're going to be looking at a house that either has a geothermal system in it, or you may be building a house and you would seriously consider putting in a geothermal system. Does anybody have even an idea, or can they tell me what a geothermal system is? Okay, so no clue about that? Yes?
Does it use like the Earth's heat to like keep your house not heating with the Earth's energy to keep your house?
That's exactly what it is. So you're utilizing... The thumbs up. The Earth, 4 feet below the surface of the Earth, it maintains a temperature of 55 degrees. Regardless, if it's 5 degrees outside, 0 degrees outside, it's always going to be 55 degrees 4 feet below the surface. So what geothermal system does is we drill wells down into the ground. And depending on how big the house is, it depends how big the heat demand is for the house to keep it warm. Depends on how deep you want to drill these wells. And what we do is we drill down and we put in, basically it's a hardened plastic tubing. So say for instance we would drill a well that would be say 400 feet deep. We would run 2 lines that go down into this 6-inch borehole, and we backfill it with this what they call a bentonite grout, and it acts like a heat exchange between the tubing and the ground. And what happens is we move a water-based solution through that pipe, which is hooked up to a geothermal heat pump which is located in the house. And what I'm going to do, I'm going to run a couple of videos so you guys can kind of see graphically what it's about. But essentially what we're doing is we are moving heat from the ground to the house. And we're doing that by running fluid through this pipe. The fluid actually absorbs the 55-degree temperature. It is pumped into the house into a geothermal heat pump that has a heat exchanger in it. It extracts the 55-degree temperature, and through the means of a refrigeration system, a compressor, and a series of coils, it jacks up the temperature to about 165 degrees. And that is then pushed through coils and fans and is distributed through the house through ductwork. It's a very basic explanation of how it works. One of the greatest things about Geo is that for every dollar that you spend to run the equipment, you can get up to $5 worth of heat out of the system. And that's what makes it so attractive from a financial standpoint. The beauty of geothermal is that it emits no carbon. It does not affect the atmosphere in any way. And you're going to hear that through these couple of videos that we're going to play for you. As compared to, say, for instance, a fossil fuel, if you're burning an oil-fired boiler or furnace, basically it burns at the highest of an efficiency rating of 86%. So 14% of your money and the heat goes up into the atmosphere, as well as a substantial amount of carbon, which contributes to the greenhouse effect and the global warming. So when I started doing geothermal in 1996, part of my motivation was to get away from oil, and working with it prior to that was not happy working with oil. I think it's a dirty fuel. It's very expensive. It's very volatile on the market as far as costs are concerned, whereas geothermal holds a very stable cost operating standpoint. So what I'd like to do at this point, unless you have any questions right at this point, okay, I'm going to run a video here that kind of shows you the basics of what geothermal is and how it works.
Between 42 and 80 degrees Fahrenheit year-round, depending on where you are in the United States. Underground, the roof is open.
All right. I am not a teacher, and I'm a contractor, and I've done a lot of trade shows and talked to a lot of people. I do a lot of sales, and so when I was asked to come here and do this, I was a little apprehensive because I've never talked to this many people in a room, and I'm used to dealing with people that are basically buying homes or older. But I think it's pretty interesting that I was asked to talk to a younger set, and I was thinking that heating systems, I remember when I was your age, I mean, I didn't know a pipe from a duct and I couldn't care less. And it wasn't until I chose my career that I obviously got interested in it. I'd like to get your impressions of a heating system. I mean, what has been your experience? Do you know what kind of heating system you have in your house? Can anybody tell me? Sorry?
Oil.
You have oil? Is it a warm air system where it comes out of ducts, or does it come out of radiators, or do you have any idea? Okay, so it comes out of registers or diffusers. Like for instance, in this school, you have mostly air. So air is being heated, and that's what comes through the ducts and basically heats the space. So I know a lot of this, talking about geothermal and how it applies to heating systems, I think to get just a basic knowledge of even what a heating system is, I think is really where we should start. But I think if you could just keep in mind that primarily a geothermal system is heated, it heats the air, and the air comes out of these ducts. And it also, does anybody have or anybody know anything about radiant floor? Have heard of that? You have?
I have a system. I have a home that has a geothermal system.
Oh, is that right?
Yeah.
Okay. And does it heat through the air ducts, or does it heat from the floor? Okay. Radiant floor heating is probably one of the best heating systems you can have, the most comfortable. And what it is that we lay piping in the floor, and then the floor is built on top of it, and you have a warm floor system. And geothermal is a great way to supply heat for that kind of system. So that's really what I'm talking about right now, is just distribution. This is how you distribute the heat. But what's really important about geothermal is that it is a way of generating the heat, and where the costs come from and the efficiencies of geothermal, and also the environmental aspect of it, especially when you guys get out in the world 5-10 years from now. The price of oil is very expensive, and it's getting even more expensive. Right now, a gallon of fuel oil, can anybody tell me what a gallon of fuel oil costs? Sandy. Okay, $3.99. The price of that oil, it goes up and down just like the price of gasoline, as you see out on the gasoline stations. So the volatility of oil it's just unpredictable. The thing about geothermal is that it's run by electricity, and the electricity is generated by power plants. And power plants cannot just arbitrarily raise prices of electricity. It has to go through committee, and it's very difficult for them to raise the price of electricity. Geothermal is always powered by electricity, so you're looking at a more stable price, a stable cost of operation. What I'd like to do is run another video, and now this video is this is from a water furnace, and water furnace is a manufacturer of geothermal heat pumps. I have been a water furnace dealer since 1996. It's a great piece of equipment. It is very reliable, and that's the other thing about geothermal units in particular. They're very reliable, can last 25 years, 25 to 30 years if taken care of. Let me just run that video. You're going to hear some similar things that were said to the previous video. This gets into a little bit more detail.
What if there was an abundant source of free, renewable energy that could be used to heat up? Waterfurnace.com, or contact your local water furnace representative.
Now, that would be me. Okay. Some things were repeated in there. I think that global warming is certainly something that I think will become talked about more and more. I think when everyone here has started their careers and have started living their lives out there in the world, I think it's going to be of an extreme interest and concern. I feel that people that come to me looking for geothermal, one of their main motivations is global warming and the amount of carbon that's released in the air. You're starting to see much more in the way of electrically run cars, hybrid cars. It's certainly going to be a big part of the future. So I'm happy to kind of play my small part in it right now. And coming here and talking to you, hopefully you'll come away with some sort of insight as to what geothermal can do. Just a couple of other things that relate to geothermal that's important. To achieve getting the temperature from the ground, drilling has to be done. Typically in the Northeast where we are, we do vertical wells. Do you remember seeing in the video the wells that went down vertically? In the Northeast there's a lot of ledge, a lot of rock ledge, so we do vertical drilling here. One of the drawbacks, unfortunately, with geothermal is it does not lend itself to every piece of property. Because when you drill, there's a big drill rig that comes in. It's a big piece of equipment, and it needs somewhat of a level landscape to do the drilling. So if you buy a house on the side of a cliff or a hill somewhere, it's going to be very difficult to achieve that. Geothermal in the Northeast is becoming more popular, but it did start in the Midwest, Oklahoma. Essentially, they have a softer earth out there. There's not that much ledge at all. So they do a lot of horizontal loops, and that's a graphic that you saw on here as well. And you'll see a lot more of that in the Midwest, much less expensive to install out there, and you'll see it out in the Midwest much more than the Northeast. But outside of the landscaping, we do need to also stay away from septic systems and also freshwater wells. Building codes are pretty strict about that. Even though the fluids that we use to do the heat transfer from the ground is non-toxic, the building authorities are very slow to catch up with this. In the past, they've used toxic chemicals to achieve the heat extraction from the ground, which is no longer the case. But we still have to maintain certain building codes to get these wells in, and sometimes properties don't lend themselves to the setbacks that are required. Properties are too small. That can be of a concern. So unfortunately, geothermal is not appropriate for every single application. But what we're seeing now as well are planned communities where if they're building, say, 30 houses, they may incorporate in the site a community pond or a lake where they can sink geothermal loops into the lake, and then all the houses can share with heat extraction from that. So planned communities, I think, are also going to be part of the future too. The building codes are becoming more and more strict. Not everyone can actually install a geothermal system unless they're up to what they call an Energy Star rated code. So it's becoming more and more difficult to install geo in just any application. And so in the future, you're going to have to qualify to have a geothermal system installed in your home. Any questions at all? One of the beauties of geothermal is that it runs on electricity, and I hear people tell me, well, what's the point if you're burning an oil-fired unit in your house? If you take that out and you put in geothermal, well, the power plant burns coal in order to produce electricity to run the geothermal unit. So you're just moving the carbon release from your home to a power plant. But the reality is there are plenty of other modes of creating electricity with hydroelectric, with wind energy, and electric solar photovoltaic panels. And if you look around, you're seeing more and more homes with solar panels on their roof. And there are plenty of tax incentives to do this. The federal government is, at this point, is offering a 30% tax credit. So if you install a geothermal system in your home, and we've done some pretty large homes where a geothermal system might cost up to $100,000, and the federal government will give that homeowner $30,000 in a tax credit for that year that it's installed. The utility companies are on this as well, and they offer substantial thousands of dollars of rebates to anyone that does purchase a geothermal system. So there's a big movement for utility companies pushing, the federal government pushing for people to get involved with purchasing geothermal systems. Well, I'm running out of material here.
How many homes have you powered at once?
I'm sorry, could you repeat that?
How many homes have you powered at one time?
At one time? Well, we usually do one house at a time. We've done some homes. There's a home in Stamford that we did, in Stamford, Connecticut, that had 10 geothermal systems in it. Overall, we've installed over 100 systems around Connecticut and Westchester County. Yes?
Can two houses ever use the same geothermal system? Connected?
Yes, you can do that. But it's not the system itself. There's two parts to the system. There's the indoor part with the equipment that generates the heat, and then there is the heat sink, or where the heat is collected in the ground, in the wells. There's actually a small housing project in New Milford. They are small townhouses. I think there's 10 of them that share in the same geothermal well. So there are projects where they have a common source to gather heat, and then that piping is distributed to each individual home. So that's being done more and more.
You said it costs about like $100,000 for one of your houses. Is that what's upon the average for putting a geothermal system?
Some of the smaller homes, and we're finding this too. There are homes out there. Anybody ever heard of a McMansion? Yes. That's a trend that's really kind of fallen off the map. Now homes are being built somewhere between, the average home between 2,500 and 3,000 square feet. To install a system for that size home, you're probably looking at around $60,000, anywhere to $50,000 to $60,000.
Now, does that vary if you, say, want to get it put in after you build your house? Does your price clearly go up?
Right, yeah. If you're doing a retrofit where you have an existing system already in place, say, for instance, you had a heating system installed, and after 5 years you decided to go with geothermal. We can utilize most of the distribution system in the house, like the ductwork. You know, if you have radiant floor, we can use that. So we take out the heating, the fossil fuel unit, and put in a geo unit in its place. And a retrofit can run $25,000, $30,000. Some of the costs, a lot of the cost is in the drilling of the wells. And the drilling of the wells is somewhat substantial. You could spend $15,000 to $16,000 on drilling of wells. But that's why the federal government is offering all these incentives to try to bring the cost down to where it's more competitive with a conventional heating system. It's getting close, but there's still more incentives that need to be put out there. Yes?
So you said it costs $60K to install it, about?
Right.
How long does it take for that to pay for itself?
That's a great question. Say, for instance, a $60,000 system. If you were to put in a conventional system, you're probably running about $30,000 to $35,000. So that difference, usually you can make that up in about 5 to 7 years. So it's pretty substantial. So, for instance, if you're heating a house with oil, say 3,000 square feet, it's possible you could spend up to $6,000 a year in oil. And if you were to put a geothermal system in, you're going to be cutting that in half, or less than half. So you're about $2,800. So you could see that it takes a little time to pay it back, but if you're staying long term in your home, it's a substantial amount of money saved over the course of, say, 20 years. You could probably put your son or daughter, through a couple of years of college, depending how much college is down the road. Yes?
You said that drilling is sort of a substantial process. How long does it take to install one of these systems?
The drilling aspect really only takes about 3 or 4 days. Vertical drilling, it doesn't take much of a footprint, or it doesn't take a lot of area to do vertical wells. But it's a matter of a drill rig coming in, setting up, depending how many wells there are. But they could do it in less than a week.
They install the whole system in less than a week?
The outside part, the drilling part. where the loops are. And that's what's called the field outside, that's the drilling, it's called the loop field. And basically it's just plastic loop that goes down in a 6-inch borehole and comes back up again. Now, there are 3 different styles, or types of loops. There's a closed loop, and there's an open loop. And actually, those are the only 2 that's being used right now. There was another style that used refrigerant that would be injected down through copper tubing into the ground to extract heat, but that's becoming less and less popular because of the toxic effect of refrigerant gas and oil. So there's a closed loop and there's an open loop. Now, a closed loop system uses basically exactly what it is. It's closed. There is a sealed pipe that's connected to the equipment inside the house, and the fluid that runs through this piping is just forever captured inside this closed loop. And you're just constantly extracting heat from the ground and then displacing it inside the house. That's the type of system that we install in my company. There's also an open loop system which uses fresh water, if you remember from the video, where they actually extract water from the ground and then extract the heat from that and then dump it into another well or dump it into a dry well, that kind of thing. From an environmental standpoint, now there are a lot of townships that frown on that because you're really kind of fooling around with the aquifer, which could also affect your neighbor. It could affect how water flows naturally. So you're seeing a lot of these, what they call open loop systems, being basically phased out. So closed loop is really where the future is.
Is it possible to install this system in urbanized areas?
They've done it, yeah. In fact, the company that does all of our drilling, Connecticut Well Company, did a huge job at the Statue of Liberty. And they can do, they've done a lot of work in the city, in New York. It just makes it a little tougher. But once you get, you know, below ground in a vertical well, I mean, it's all doable. It's all doable. Yes?
Are there any risks or dangers that you have to worry about when the system's installed? Like, has there ever been like a malfunction in the machine in the house?
No, not really. No, the pipe, the tubing, the loop that goes in the ground, it's a high density plastic. This stuff is pretty tough. It's what they use when they run natural gas lines, like these main gas lines, when they, you know, when they run it across the United States. The piping will not burst. The fluid that's in it is a non-toxic. It's a water-based antifreeze solution. And the reason that it has to be antifreeze is because when you're extracting the heat from the ground, it's going to be 55 degrees below the frost line, which is 4 feet below grade. When you're talking about long run times in the middle of winter when it's 0 degrees out, these systems are going to be running for long periods of time to keep the house warm. So the extraction of the heat below ground can get below 32 degrees. So that's why you need some antifreeze in the solution to prevent it from freezing up. But even at 32 degrees, you're extracting a fair amount of heat that still can keep the house warm, even at 0 degrees outside temperature. But to answer your question, no, there's really, it's a non-toxic solution. It's propylene glycol, in which they use in food preservative. They use it in wine. Believe it or not, if you buy the stuff that's not so great. No, there's no toxic potential for any environmental problems, anything like that. No. Yes?
What's the average lifespan of the system?
Well, the loops that go in the ground, they have from the manufacturer a 55-year warranty. But just like you've heard, you know, the plastic water bottles, they think that this will be at a landfill for probably 2,000 years. Same thing with this pipe. It's not going anywhere. It's going to be in the ground. You could probably hand your house over to your kids and it still would be there with no problem, and on and on.
To
Yes?
retrofit, say, like a dorm here,
Mm-hmm.
how expensive would that be? I mean, that's a pretty big thing. That's going to be a pretty big deal to do.
It really does depend on the distribution system that you have. And typically, ductwork is where it lends itself the best. So if you have the ductwork, that's like 70% of the job already, so you don't have to worry about that.
So the old really inefficient ones that have, you guys who lived in Duffy, who have those heaters that bang and the steam ones.
The steam.
That would be very expensive to do.
Yeah, because you'd have to install a ducted system for that. That's the thing with geothermal. It's a low temperature heat. I don't know, do any of you guys have like steam radiators in your house at home? You do, steam radiators? Okay, hot water baseboard. Those things, they work off a very high temperature. You could get up to 180 degrees there. The geothermal system can only generate temperatures up to 130 degrees. So it does not lend itself to older steam systems or hot water systems or hot water baseboard. It does not work in that application. They are now, though, manufacturing hot water baseboard, a high efficiency baseboard, so that it can work. But once again, I mean, you're sacrificing aesthetics. So you're going to see this big radiator, but they're working on that too. But to answer your question as far as cost is concerned, it really does depend on the space and how much space you're talking about conditioning. Anything else? Sandy?
We're at the end. Thank you guys. We want to thank you.
Oh, great. Oh. Thank you very much. You guys were great. I appreciate it.
I've got a question.
Oh, sure.
Is your house powered by geothermal?
No, you bet. I got a great discount.